G'day viewers, well I went picking for car parts with my neighbour, fixing his car up yesterday, and at the wreckers I came across this UPS. I've ripped this transformer out of it. The rest is pretty much scrap, but this is the only thing that was left untouched. So you put normally the inverter steps to 24 volts from the battery, or 12 or 24 volts, steps it, converts it, the inverter converts it to 24 volts AC at 50 Hertz, and that goes in here. All those amps in the battery goes in there. Out here comes 240 volts AC, 50 Hertz. Well, I'm going to use this secondary as my primary for the 240 volt input and get 24 volts very high current out. I got the circuit breaker with it too, so I'll put all of that. I'll need a bigger rectifier though. That's a 6-amp rectifier. That thing's going to go bang if I short that out on this. So let's solder the power cord on. See what happens. Got the variacs for test purposes. Make sure I've got the right tap so it runs correctly. We'll start having some fun. Just to make a bloody good 24 volt power supply with this. Variac on 0, power on. For test purposes. All good. All good. Beautiful. That's right. Beautiful. Perfect. That's our proper 240 volt primer there. Another 120. I originally thought this was a 120 volt tap, and you put these two in series, but for some reason it's got two outputs: lower current 240 volt and a higher current 240 volt input. Handy. Alright, it's time to unplug that and we'll solder it all properly to confirm that's definitely the main input there. We'll start having some fun. Okay, it's properly done there. Well, nice and heat shrunk. Properly soldered. Let's turn it on. Not a bit of inrush. Multimeter, and we'll test it. A lot of volts in this transformer. I mean, not volts, current. Gotta find the right wire first. Oh, I've got it on DC. I've got it on AC, whoops. I wonder I'm not getting any voltage. Ah, cool. Nearly 8 volts on the brown tap off the red one. Between the big red wire and into the blue and the brown, I got 8 volts. Between the brown and the blue, 15.92 volts. Little wire, a little red one, 8 volts. The 2 red wires, nothing. There you go, 15 volt tap there. This will charge up some bloody car batteries. Okay, it's blue on the brown, I think. Just the blue on the brown to get a good voltage output. Yep, 15.9 volts. That'll make a good car battery charger, that one. Alright, let's put the variac on it, slowly crank it up and see how much primary current it draws. Between there and there it's 15 volts. That's 16 volts, so that's not too bad. It's only out of a small UPS. Okay, power consumption test. Got this little lead here. I'll do a little short out test, so I'll put that on there. 15 volt tap on 0. Okay, turn it up. There you go, bad connection there. Wires are getting pretty hot. Turn it down. That got to about 2 amps on the primary side. I got up to about 160 volts. So that's pretty decent output. I might need a chunkier here, power off. Bit nice and soft and rubbery now. Get your vice grips and we'll try it again. Okay, variacs on 0, power on. One 60 volts input, 5 amps, 240 volts. Oh yeah, 13 amps it pulls at 240 volts input, short circuit. Unplug safety first. A little bit warm in there. So I'm going to have to wire a 10 amp breaker in series of this. So if I do experiments on this side of the output, the 10 amp breaker is going to stop the primary from getting overloaded. Yeah, it's a little bit warm, but 13 amps at 240 volts, a pretty beefy little transformer. That pulls almost as much as a mott does. Alright, let's make a box or something for it and put a circuit breaker in it for safety. Okay, viewers, in order to hook this up in line with the primary, I'll need a good case. I reckon this smart meter case, pretty durable bloody plastic polycarbonate. The best thing to put this transformer in, it's really durable material. Just find a way of bolting it down. That'll go through the side. My primary side circuit breaker. Properly insulate everything and secure everything down. I'll make a little slit so there's 7 volt and the 15 volt taps come out. And that'll be it. I reckon that'd be cool. The next challenge is finding a way to secure that transformer down. Just cut these little bloody standoffs, try and get those off, shave them down. Maybe we could clamp this bloody transformer down somehow. Okay viewers, I'm going to have to try and think of a better case to put this in, because it has to have vent holes in it too. I mean, the smart meter case is more than bloody strong and compact enough, but there's no decent lugs to properly secure the transformer. And there's not enough circulation for air to get through it. Okay, there's a 12 gauge wires here. This is a 15 volt tap. I'm going to test it with this circuit breaker instead of using this on the primary side. Just see how effective this is, because this is just as effective. Instead of putting this on the primary side, keep that for something else. It's bloody handy to have those little breakers. It's a little 10 amp breaker like in a power board. It's actually quite a good quality little unit. 10 amp, 125 or 250 volt AC and 50 volts DC. It's got the cord grip nuts. Hard to find those that are right grip nuts on them, so I'll keep that. Alright, let's give it a test. Look at the gauge or the amp meter. Bang, and tripped. And just got up to 10 amps and it tripped already. That's good, very effective. All I need now is a decent 100 amp bridge rectifier for the output, and that'll be my main isolator. So if it shorts out, this will protect everything. Works quite well on this circuit. Don't know about this one here though. Not much on there. There you go. I'll try and think of a better way to design a case for this bloody thing, so thanks for watching.